So I wanted to make another video going through the special right triangles and how to use the relationships between the legs and the hypotenuse to find some missing sides. So with this IXL example, what I know is that I have a 45, 45, 90 special right triangle. Now, the pattern with a 45, 45, 90 special right is this square root of 2 relationship between the hypotenuse and the legs. Now, the 45, 45, 90 is the simplest of the special right triangles because there's only one relationship for you to worry about. The legs are the same, so if you know the legs and you want the hypotenuse, you're going to multiply by square root of 2. If you're going the other direction, let's say you know the hypotenuse and you want the leg, you're going to divide by square root of 2. That being said, the reason why when we go from leg to hypotenuse we multiply is because our leg is getting bigger. Whenever we want something to get bigger, we always multiply. When I'm reversing that relationship, for example, when I have the hypotenuse and I want a leg, the reason why I divide is because the hypotenuse is going to get smaller. The hypotenuse should always be the largest side in a right triangle. So when I'm looking for a leg, I'm always going to divide. If I have the hypotenuse and I'm looking for a leg, I will always divide. So if I go back to this example, I have a leg and I'm looking for a hypotenuse. Now in a 45, 45, 90, all I need to do is take my leg, multiply by the square root of 2, because again, I want it to get larger. I want the hypotenuse. And this is actually as simple as my answer can get. I cannot combine 7 and square root of 2 because these are not like terms. 7 is a whole number, and this is a radical number. They do not combine with each other. So 7 square root of 2 would be my final answer. This question is a different kind of special right triangle. This is a 30, 60, 90 special right triangle, which has its own slightly more complicated side relationship. A 30, 60, 90 special right triangle, first of all depends on the short leg. Okay, you need the short leg to be able to do anything involving a 30, 60, 90 triangle. Now, the short leg is always across from the 30-degree angle. They're always on opposite sides of the triangle from one another. The long leg is always across from the 60-degree angle, and the hypotenuse is still always across from the 90. Now, the short leg and the hypotenuse have the easiest relationship. The short leg times 2 is the hypotenuse, and the other way, the hypotenuse divided by 2 is the short leg. So short leg and hypotenuse have this double or half relationship. The short leg and the long leg are slightly more complicated. The short leg times square root of 3 is the long leg, whereas the long leg divided by square root of 3 will give me the short one. Another note that I just want to make briefly is that you cannot go directly between the hypotenuse and the long leg. You need to find the length of the short leg in between these steps. So let's go back to the example problem that I was doing on IXL with a 30, 60, 90 triangle. Now, in this problem, I have the length of the side that's across from the 30-degree angle. So I know the short leg. I want the leg across from the 90-degree angle, which is the hypotenuse. The relationship between the short leg and the hypotenuse is times 2. Again, I want the side to get larger. The hypotenuse is the largest side, so I need to multiply by 2. 16 meters is my answer. In a problem like this, I have the side across from the 60-degree angle. I want the side across from the 30. To go from the long leg to the short leg, I have to divide by the square root of 3. The relationship between the long leg and the short leg is square root of 3, and I want this side to now get smaller. So my final answer here would be 7. 45, 45, 90 has a square root of 2 relationship. I'm going from the hypotenuse to a leg, so I need to divide by a square root of 2. They cancel each other out. My leg would be 9. In this problem, I have the hypotenuse because it's across from the 90-degree angle. I want the short leg because it's across from the 30. The relationship between hypotenuse and short leg is double. Because I'm starting with the hypotenuse and I want the shorter leg, I'm going to divide my hypotenuse by 2. 10 is my answer. So let me find one where we have to take it in 2 steps. Okay, so here is one where we have the longer leg is what we're trying to find, and I'm starting with the length of the hypotenuse. There's no relationship between the hypotenuse and the long leg. There's no direct relationship. I need to find the length of my short leg first, and then I can continue on to find the longer one. Now, the relationship between the hypotenuse and the shorter leg of a 30, 60, 90 is double. Since I'm starting with the hypotenuse and I want the short leg, I need to divide by 2. Again, I'm starting with the hypotenuse. That's why I'm using this double relationship. So my short leg is 9. Now, when I want the length of my longer leg, the short leg and the longer leg have this square root of 3 relationship. Now, because I'm starting with the short leg and moving to the long one, I'm going to multiply by square root of 3. My answer, 9 square root 3. I hope this video was a little bit more helpful. I'm happy to jump on a Google Hangout with anyone who still needs some help.